Okay, now I know in science we have to look at reading graphs and charts. Now, this particular graph, I noticed it a couple times on the test, and this graph, it has a special function, and I want you to get a little of good understanding of why we actually use this graph and how to read it. Okay, so as you can see, we're looking at water, okay? I'm going to change the green. Okay, so you can tell we're looking at water. That's the label here. And let's look at some more labels here. And the reason why I chose water because it's probably the one that's going to show up. But it may not be. Sometimes they use carbon. But water is something that we're familiar with. We're familiar with the substance, and we know a lot about it when it comes to freezing point, boiling point, things like that. So that's why I'm using water. Okay, so you see on this side of the chart here, this is giving you the temperature. And we know, or if you don't, you need to know that the freezing point of water is 0. And we know that the boiling point of water is 100 when it comes to degrees Celsius. Now, of course, if this was Fahrenheit, then this would be 32, and here would be the boiling point would be 212. But usually in science, it's going to be in the scientific notation as opposed to the standard. In fact, very rarely do you find Fahrenheit used in science. Okay, if only, except maybe to teach you the difference between Fahrenheit and Celsius. Okay, so, and here you see on this side, here, this direction is showing you that it's energy being input. And when it's energy input, it's usually in the form of heat because that is the energy that we use to change the states of matter of a substance. Okay, and this is, and really, a lot of times, instead of saying the word energy input, you see the word time. So as time progresses, energy is being input into the substance, which in this case is water. This is the state of matter that these are the states of matter that they're in, and this is the changes that occur. So anything below 0, water is in the form of ice, which is the solid form of water. And here you can see that once it gets to 0, then this is the point that they're teaching, is this spot right here. That energy is still being put into the water, but the temperature is not going up. And the reason for that is because when substances are changing from one state of matter to the other one, the temperature does not change until all of the substance is changed from one state to the next state. So as water, you'll have 0-degree water all the way until all the ice changes into the liquid form of water. And then it'll start going up in temperature. And this will continue to occur. You'll get the raising of the temperature until again you get to its boiling point or evaporation. Evaporation, boiling. Evaporation is just boiling with water at a temperature lower than, well, anyway, boiling, evaporation. And this is when water changes from a solid to a liquid. So again, you have the same situation here where energy is being input into the liquid water, but the temperature is not rising. So, and as time progresses, more energy is being put into the liquid water, but the temperature is not rising. And then when all of the water starts to change from water to steam, which is gas water, that's funny, then the temperature starts to go up. And now this water in gas form, which is steam, the temperature will start rising on that substance. So every element, every substance has a chart that looks like this. And that's what's important, because scientists want to know what is that temperature when it starts to convert from one state to the next. What is the other temperature when it changes from one state to the next? That's what's important about this chart. Okay, I think that'll help you out when you get exposed to this chart, and I think you'll be ready. It won't look like, what in the world is this? You'll be, oh, I know what this is. All right, that's it.